The broadcast is now starting. All attendees are in listen-only mode.
Hello everybody, and a very warm welcome to the December edition of the Mobile IT Community of Interest. Thank you very much for joining us today. The title for today's session is Visual Data Analytics for Field Reporting and Project Controls. Thanks very much for joining us. Just before we get started, I'd like to review how to use the GoToWebinar system in order to optimize your experience. I'll just explain how you can interact with the community meeting using the system. Everybody is currently set to a muted mic due to many participants on the call. However, you can get the audio over your telephone or the speakers of your computer that may improve sound quality. The panel will hide automatically using the orange arrow. Forward any questions that come up during the session using the questions tab. If you'd like to remain anonymous, just say so. Also, we have some live poll questions at the beginning, which we'll go through. There's two of those. We also have a panel session at the end. I want to talk about the community itself. The objective of our community is to showcase or show and tell the mobility solutions currently being developed and adopted within the capital projects industry. We strive to achieve this goal by presenting the latest use cases of mobile IT adoption and also by allowing the breadth of the community participants to expose their perspective on these technology applications. We have been delivering these use cases and industry perspectives through various channels, including the monthly meetings such as this one, virtual live discussions, documentation, reports, gatherings, and also by facilitating the creation of research and development projects within both of the organisations responsible today. The community is a partnership venture between Fiatech and Comet. Fiatech is a member-based organisation with the objective of improving the productivity of capital projects throughout the deployment of technology. And the goal is to improve productivity in the capital project sector through the leadership in global development and adoption of innovation practice. Comet is a member-based organisation in the UK. Its principal aim is to learn from experience, delivering measurable business benefits in terms of adoption of mobile technology. This partnership therefore supports the work and objectives of the community. So who's in the community? The community has been running for 4 years now. We've had well over 500 organisations located in over 60 countries so far. We've got participants located across the globe. We've brought together regular participation from Asia, South America and elsewhere, including Europe and North America. The industry response so far has been very good, and we're continuously working to meet the needs and suggestions of our participants. So before I move on, I just want to talk about capital facilities and why the industry has not seen the productivity improvements it should do with the technology that's being deployed. The biggest barriers, companies are siloed, not just within, but across the industry. Each project is looked at unique, and any innovation is often site-specific and doesn't go any further. We've got lack of data capture on performance and value case. This webinar showcases that today. We've got limited shared experience amongst owners, EPC, solution providers, and so on. And we've got limited knowledge available of technologies and best practices. And the final one there is we've got this lack of change readiness within the companies that participate or operate within the capital project sector. So, thank you for listening to that. The main presentation, just before we move on, visual data analytics for field reporting and project controls. Manny will explain how you can use your existing visual data from images and videos to point clouds and enable proactive field reporting and project controls on construction sites. This webinar will present two specific systems and workflows, and I'll just give you a couple of those points without going into detail. So, markerless and infrastructure independent field reporting, and that is leveraging simple digital images taken using commodity smartphones or tablets. And the second part is proactive project controls, again using images and videos from drones through smartphones to automatically generate 3D models over a project timeline. I'll introduce now our participants today. I mentioned Manny, Dr. Manny Golpava is Associate Professor of Civil Engineering, Computer Science and Technology at the University of Illinois, Urbana-Champaign. Manny's work in the area of computer vision, machine learning and building information modeling, and has been the recipient of many awards, including the 2017 ENR Young Professional Award, the 2016 Dan Halpin Award for Scholarship in Construction, and the 2013 James Crowe's Medal for Innovation in Civil Engineering from the Association of Civil Engineering. 2013 and 2010 Fiatech SETI Awards and numerous Best Journal and Conference Paper Awards. We have also Ryan Girai of CCC. Ryan is the Manager of Innovation and Development of 3D and Visual Projects Control Solutions at CCC. Ryan has almost 20 years of experience in bringing innovation to the EPC industry. He is a US patent holder and a C3D technical manager. We have Todd Sutton. Todd's a senior project manager at Zachary Construction. He has over 28 years in the construction industry with various assignments related to project management. He has assisted with various business units to find process-based solutions through the implementation of technologies or construction methods to assist in project execution. We also have Rami Santini. Rami is Head of Graphics Development at CCT International. Rami has more than 10 years of experience in computer graphics and HPC. He currently works on developing HPC and cutting-edge technology to solve industry challenges. So I'll hand you over to Manny, who's going to take us through the main body of the session. But before I do that, what I'd like to do is I've got a couple of poll questions here that will help us further on in the presentation. And just bear with me a second, I'm going to just launch the first poll question. So how do you currently track progress on your construction sites? And please choose the most dominant type in your organization. So I'm launching that now. Please vote away. So as I said, this may help us a little bit further on in the presentation when we get to the panel session. Okay, thanks for that. I'll close that out and I will just share that. Excuse me. So, we've got 16% paper-based daily reports by trades, 68% field engineers daily reports and inspection, 12% mobile apps for daily reports, 4% offline BIM-driven tracking. Manny, can I bring you into this? Can you give me your thoughts on what you see?
Absolutely. Thank you, Stuart. Yes, I think the poll responses are what we were expecting, that majority of companies and today's practices are evolving around daily reports and inspection logs. I'll be happy to comment on it when we get to our industry challenges in a moment. So we can maybe continue with the second poll.
Okay, thank you for that. So the second poll question is, what forms of visual data capture does your organization currently use for tracking progress on construction sites? Okay, I'll close that one out. Thanks everybody for voting. And I'll share that. Okay, 52% photo video logs, fixed cameras. 13% photo video logs, fixed cameras and drones.
Wonderful. Shows the opportunity we have for streamlining tracking progress by contrasting visual data as a feedback from the job site with the 3D models that we use as part of our construction coordination. And we'd be happy to touch on it in a moment.
Okay, I'm now going to hand over to you, Manny.
Wonderful. Can you maybe make me presenter, please, Stuart?
Yep.
Great. Wonderful. Again, thank you very much to everyone who's joined our webinar today. So with the polls and with the focus that Stuart introduced, our intent is to introduce you to some of the challenges that we see today in the industry in terms of progress tracking. And shortly after, I'm going to touch on the opportunities associated with visual data. And then I'm going to show you two use cases. One, Mars rover, a project that was sponsored by CCC and Fiatech. We've done a number of validations and case studies around that. And second component, a study that we had Fiatech, CCC, and Zachary join on using visual production models for the purpose of streamlining project controls on job sites. But before I get into that, I want to really start by introducing you to what we see as an opportunity in the construction industry today. So 2017 has been a great year for construction. The value put in place in the US has exceeded $1.2 trillion. We've not had this number for the past 11 years. So this is quite impressive in terms of how much resources are going to construction today. This is not only limited to the US. Globally speaking, the percentage of the GDP that's been spent on construction has also significantly grown. While these numbers are impressive, the reports that are being published by McKinsey and Company are still showing the same status that we've seen for productivity over the past 10 to 15 years. In fact, McKinsey's report shows that the annual productivity growth in construction sector has only been close to about 1%, while in non-construction industries, that number has been closer to about 3%. This gap of 2% between that 1% in construction versus others represents $1.6 trillion of additional value that could be added if we try to bring productivity in construction in par to what we see in manufacturing and other sectors. This number, $1.6 trillion, is in fact larger than the total value, total money that we put in place in construction in the US. So what does it really mean? This is number in terms of productivity. Interestingly enough, the reports that are coming from McKinsey and Company and others are transforming this lack of productivity in terms of what it means for completion of the projects on time and what it means for cost. The reports that have been published by McKinsey primarily focus on capital projects, and their reports out of 2015, 2016 show that 98% of projects that are more than $1 billion in total value are actually behind the schedule and over budget. Now, to represent that in the context of buildings and more common projects, I wanted to highlight the report that was published by ENR in 2016. So what you see on the screen is a survey that was done by ENR, and it shows that in commercial and industrial building sector today, more than 50% of projects are behind the schedule and over budget. Those are the gray bars that you see. Not only this is happening to our typical projects, even in those projects where we are adopting best project management strategies, including lean construction, we still see a major number of projects that are behind the schedule and over budget. That number is somewhere between 10 to 20%. To better understand the root causes for such a performance when it comes to schedule and cost, I wanted to take you back to the cycle of planning, conducting the work, checking and adjusting. Whether you're adopting earned value analysis as part of your project controls, or you're looking at the lean construction cycle, you implement pool planning, you engage your trades in a weekly work planning process, you coordinate the work on a daily basis, and you try to learn from performance by using metrics such as percent plan complete. There are a number of issues associated with the cycle that are directly contributing to why projects are behind the schedule and over budget. So I want to specifically touch on these pain points. The number one pain point associated with the project process of planning, monitoring, and control today is inadequate communication. Reports that are coming out by McKinsey and Company and others are showing that today our understanding among owners, contractors, and subcontractors in terms of how much progress is being achieved on job sites is not consistent. These numbers are not consistent, and as we saw from the quick poll, majority of the companies are still relying on daily reports. Oftentimes, these reports are filled out by our subs or the trades, and unfortunately, they do not carry enough information for us to be able to make sense of how much real progress has been made. We don't usually trust these reports, and the result of it, we wait for an entire week for our trades and the subs to come back to a coordination meeting, and again, we ask them to stand up and color code or document the progress that I've made over the past week. So essentially, from the time that an issue happens to the time that that issue gets communicated to us, we've effectively lost 1 week worth of work to address those problems. Our problems are only not associated with what we do for reporting, but it also has to do with our planning. Over the past 10, 20 years, perhaps closer to 20 years, our practices of planning, master planning, has significantly advanced. But when it comes to us understanding how much work could be done on a daily basis or on a weekly basis, there's still a whole lot of room for improvement. Part of it has to do with the fact that even in those projects where we are bringing last planners to be part of our planning project, we still see a lot of misconnection to the actual progress. Most of the people who are involved in the planning do not walk on the job site on a daily basis to see how much progress gets achieved. And if those numbers are being reported, they're not being integrated as a basis of the plan, so we can actually improve and address the issues before they surface on the job site. And the last pain point that we see with the cycle of planning, doing, checking, and adjusting is insufficient risk management. Today, we still use metrics from earned value, schedule performance index, cost performance index, or for lean construction practices, we use percent plan complete. These are great metrics, but they're retroactive. What they mean is that they help us understand success and failure in the past, but they do not offer any insight about the potential problems that are about to happen when it comes to looking at the schedule. So instead of retroactive practices, what we really need is proactive, because things in construction don't repeat. If they don't repeat, opportunities for addressing them becomes significantly minimal. So instead, we need proactive strategies that can identify risk on the job site, communicate that to our trades, so we can tap off potential delays from happening. So what is the opportunity that we see? Earlier, we mentioned about visual data. The growth and expansion of visual data on our job sites has been on two fronts. On one side, building information modeling has become a dominant method for communicating data across various life cycles. BIM is dominantly being used for design. A lot of construction companies are also using it for clash detection and coordination purposes. But we also see that as a basis of assessing quality of the schedule in 4D BIM. What we see as an opportunity is to extend the application of the BIM that already exists and use that as a baseline for tracking progress. Be able to use that to communicate who does what work in what location, and see if we can understand how much work is being done per work location, per work package, or per trade that we have on the job site. The other opportunity that we see is with respect to the feedback to that plan, the visual data that's being captured on job site, which is not actionable today. So as you saw in the second poll question, a lot of companies are today capturing daily photo logs. We all walk around with our smartphones, take photos, videos from various locations. We use professional photography, an example of a company that you see in the middle that's based on reports that have been published by them and our communication. On most of their job sites, they capture close to about 1,000 images per day. Time-lapse cameras in 2017, they've almost become dominant. So we see 1 or 2 cameras per almost every site. People are using action cameras to walk indoor locations, videotape work, and being able to use that for various applications. Drones have provided a significant opportunity for this visual data capture. The speed and amount of visual data that is being captured has significantly grown. And lastly, as we've seen through various great use cases that Fiatech has presented over the past 10 years, laser scanning has also become a dominant tool. So all of these various kinds of visual data could be used as a feedback to the plan, but as they are today, they are not actionable. So what we've been focusing on as part of the effort that we started at Fiatech with CCC and also with Zachary is to see how we can go ahead and integrate our visual data with the BIM in form of visual production management systems. The idea is pretty simple. Our intent is to take advantage of the most inexpensive form of visual data, being images and videos, automatically generate 3D point cloud models from that visual data over a project timeline, integrate them with the BIM and the schedule so we can form our visual production models. Then use these visual production models that show you the reality on the job site versus the plan to understand progress and productivity and communicate the work that needs to be done on a daily basis. We also have looked into machine learning algorithms and their capability in terms of identifying risk based on the trend of progress and productivity, and see if we can share that insight with our project teams so they can tap off problems before they surface on the job site. So the intent is to be able to take these into coordination meetings, use reports that are all visual, that show you how much work was expected to be done, what is actual, and use that as the basis of our coordination. So a superintendent can transform our coordination to center around risk and how we can tap it off before it surfaces on our job site. So with that, I want to give you a broad picture of what this visual production management cycle looks like. It all starts with a visual data capture. So we have images, videos, and perhaps 360 that would be captured through cloud-based engines. For example, the one that we've also developed. We can generate reality models over project timeline. Then BIM that is being used for coordination will be integrated with the schedule and will form what we call a production level 4D BIM. The production level 4D BIM would be integrated with the reality model and will form a 4D visual production environment. Within this model, we will be tracking progress per location, per task, per work package. We will track productivity by tying the input, being the worker hour, and then using machine learning algorithms, we can identify risk, bring that in a form factor that the superintendent, who may not be savvy with BIM, will be able to use it on the job site, revise the basis of the plan, look at the schedule, and use that as a step for the next cycle. So in the spirit of that, we looked into two specific projects. Mars Rover project, a project that was based on a technology that was developed earlier. And this project was supported directly by CCC and Fiatech with the intent of improving how we do visual field reporting. So the idea was that now that we have all this visual data, the images and videos, now we have the ability to generate point clouds with them. Also, we do a lot of laser scanning. What are the opportunities that we can take advantage of that existing visual data to localize where our field engineers are in 3D on the job site? The intent is to take advantage of these photos, automatically understand where we are on the job site, to be able to offer on-demand and mobile access to project information. Imagine you're walking on the job site, you take a photo. We want you to really be able to get access to the information, find your location, let's say with respect to a building information model, and be able to use that as a basis of extracting information or reporting back. So what was the key requirement as part of this project? We wanted to make sure we have a rather real-time or near real-time identification of position and orientation. Now, over the years, perhaps over the past 10 years, a number of types of technologies have been introduced that can facilitate this. We have GPS, we have ultra-wideband technology, we have 3G and 4G that can provide you with access to cloud-based systems, but each and every one of them, in their own ways, they can create challenges. So we knew that connectivity to data and connectivity to wireless can become an issue. So we wanted to make sure not only we can offer a cloud-based architecture for being able to tap into this mobile and on-demand access of information, but rather we would also have a alternative solution that can work directly on the mobile phone to be able to provide access to specific information you're interested in. So the idea was simple. We wanted the users to walk around with their existing smartphone, be able to take photos. The photo would be matched against the 3D models that we've already generated, and by identifying location and orientation of the user, be able to get access to information or let the user directly provide information as an overlay on the image or as an attachment to the building information modeling elements. Now, in the context of BIM, the idea was that for us to be able to take photo, understand location and orientation of the photo, and overlay a picture of BIM over the image so we'll be able to see that. So the idea, again, is to find location orientation as it relates to a building information model, overlay that on BIM, and be able to show that from various perspectives, filter that based on the trait of interest, and making sure that this technology is reliable so you can actually use it from various points of view and perspectives. Now, the good news is that when we wanted to start this project, we immediately learned about the significant amount of development that has been done in CCC. So over the past, I believe, 4 to 5 years, and perhaps a little bit beyond, CCC has developed a C3D mobile solution that provides access to BIM data on the job site. It also has a capability of providing a BIM-driven progress tracking capability. So while you're on the job site, not only get access to your project information, but you can directly provide that feedback in terms of how much progress is being made, our punch list items, or quality control items directly within the BIM environment. Now, using that as an opportunity and using the capability of localizing a user with respect to a point cloud, we wanted to see if we can align our point clouds to BIM, be able to localize and orient a user with respect to BIM without necessarily using GPS or capabilities associated with location tracking, and then be able to tap into that wealth of information that's being stored in CCC's C3D data. So the objective was to conduct a pilot project, Mars rover, identify if we can locate and track position and orientation of the users. And again, we did not want to add new kinds of visual data. Rather, we wanted to take advantage of existing visual data that are being captured by smartphone and be able to localize and orient users in space. Now, what are the specific requirements that we wanted to tap into? One, obviously we want to make sure that the field reporting can be done on commodity mobile phones. C3D solution from CCC was already offering that capability. We wanted to make sure we can associate project information with 3D elements at any desired level of abstraction. What I mean by that is, regardless of what work breakdown structure or what model breakdown structure we have in the model, the user to be able to associate punch items, quality items, or even progress items or progress reports with respect to the plan. We wanted to have high precision association of information to these models within 2 to 5 seconds. So the intent was really not to develop a live augmented reality model, even putting aside the safety issues associated to that. Rather, we wanted to make sure we have a high precision solution that within a few seconds can augment still photos, static images, with a picture of the BIM, so we can use that as the basis of our field reporting. We wanted to make sure that this also would be in form of a cloud-based platform, and it would work with or without BIM. So again, 3 components: tracking location and orientation of any user with smartphones with respect to a point cloud, being able to offer query and content authoring capabilities with or without BIM, and be able to access and share most updated project information in the event that the user happens to be connected to data. So as part of that, we had abilities to align static images with 3D point cloud models, but we also looked into capabilities associated with taking advantage of videos to be able to map locations in 3D and identify orientation of the user to that. So I'm showing you an example of a user walking around with a consumer-grade video camera, and what you see on the right side is a live video that was being captured, and in a one-to-one computation time, that video feed is actually transforming into a point cloud model. So on the left side, you can actually see a sparse point cloud is being reconstructed on the job site, but in the meantime that we're mapping the environment in 3D, you can identify location and orientation of the user. So basically every one of those blue pyramids you see in the scene is a location that the user has actually taken one of these video frames from. This is actually quite long video, but what I want to do is I want to advance this a little bit further for you. So you can actually say the user continues coming back. It would walk back into the same corridor, and it can identify that this is a location that has already been observed before, and we'll be able to localize the user against it. This continues on for another few seconds. I'm going to minute 3, 4. So as you can see, an entire floor of a hotel structure, in this case, is actually being mapped under about 5 minutes. And within 5 minutes, we can get a understanding of complete location and orientation of this video feed as it relates to that space. Now, the moment that we have this capability, then we can feed it into our capabilities for generating dense point cloud models. So we can generate point cloud models like the ones that we've already shown you before, and then we can use that as the basis of alignment, meaning that once this map is done, let's say on a on a Friday, the coming week when we have workers coming back or our field engineers, the moment that they start taking photos, we can always localize them against this map. This map can be also aligned with BIM, indoor or outdoors, and be able to offer you that capability of getting access to the BIM information. Now, as part of this, we wanted to offer a number of capabilities. One was to be able to directly tap into the content of the images and be able to work with any level of abstraction. So in this case, I'm showcasing ability to overlay BIM on an image, but as you can see, the user is manually reporting from any desired perspective images that could be captured with a smartphone, and it's basically color coding or providing percent complete as it relates to tasks, quality items, or even punch lists. So you see the different capabilities, and as you can see, these color codings would all remain preserved over timeline. You can start with a BIM perspective. You can have ways by which you can interact with the content. You can scratch the surface of your BIM image, and you can go back in time and get access to the most relevant images. You can also look into capabilities of doing that with respect to an image. Sorry, I moved too fast here.
Here we show the circle brush selection mode.
So we can actually click on the surface of the image. We can brush over the surface of the image, and we can go back and forth, find views of BIM, find views of other images that have been captured over time. Now, obviously, as part of this, we wanted to do a integration with CCC's C3D solution. So we worked on a number of use cases. One was to see how we can tap into existing laser scanning point cloud data. As part of that, we wanted to see if we can tap into the images that are also being captured with laser scanning as the basis of mapping and localization. Then we started working on the image-based capabilities. And lastly, we also wanted to work on video-based mapping and localization capabilities, which is essentially what we've offered as part of this project. And it was really important to us to do that because we wanted to make sure if the user doesn't have access to data, or if they don't have access to wireless, we will be able to achieve this mapping and localization with respect to the maps that will be stored on the client device, being the device that's being used by the user to achieve mapping. So we achieved a number of objectives as part of a number of case studies that we've done as part of this project, one of which was to be able to tap into videos directly, do 3D reconstruction, and achieve mapping in real time on commodity phones. Second was when it comes to localizing users, meaning that you go back to the scene, you would use the same device or same type of device, you take photos, be able to map, identify your location in near real time with respect to that environment. We wanted to make sure we can do point cloud to point cloud registration, whether these point clouds are all captured in the same date or captured over a project timeline. We also wanted to make sure that the system can take advantage of multiple BIM files as part of our coordination efforts and be able to localize users with respect to that point cloud and with respect to that BIM. Now, the second component of our work that we've done with CCC and also Zachary was to see how we can tap into this data and go beyond reporting capabilities and contrasting reality with a plan to report progress, productivity, and risk. So again, tap into the same type of data that I mentioned before. This time, we wanted to make sure we can integrate all types of visual data and specifically focus on some of the capabilities that has to do with drones. So I'm showing you some examples. Over the past few years, a number of even Fiatech members have acquired capabilities of photogrammetry, or they've also been in quite a few startup companies in this space. This happens to be the solution that we've developed that takes in images, videos, and 360, automatically generates point clouds over a project timeline, and can offer you on-demand access to images. So you can click on any desired viewpoint that you have. You can go into that 3D viewpoint as it relates to that location, and then you will be able to get access to the high-resolution image. While you're within this web-based integrated environment, you can actually do measurements. You can measure length, you can measure volumes, you can measure height, and things of that nature that are relevant to your progress tracking capabilities. Or you can simply annotate directly on the contents of an image. Then we also added the capability of tracking volumes over time. Now, some of these capabilities are currently available in offline solutions that software vendors offer. We want to offer this as part of a web-based system. So we started looking to direct volumetric measurement from point clouds and not simply orthophotos that could be generated by drone images. We've actually done a pilot project this time with Zachary at one of their sites to be able to also expand the application of this to stockpile measurement, being able to measure cut and fill on demand and be able to track changes of volumes over a project timeline. Now, these reality models should be integrated regardless of these being part of our Mars rover capability or part of our reporting capability. So the idea was that without using GPS, without using any ground control points, how can we localize new images with respect to previous models? So in this case, at the bottom of the screen, you can actually see a timeline. Every one of these bubbles represents one of the point cloud models. So I'm starting with August 3rd. You can see August 31st now, September 14th, September 21st. So basically, at any of these dates, in this case, on this job site, drones were being operated, images are captured, 3D models are generated, and the models are automatically aligned without using any GPS tags or ground control points. We've done a number of case studies around this. The example that I'm showing you right now is a site from Zachary, where we've tested this capability. It was important to have a complete automated workflow, meaning that there will be a web-based platform that the user will be able to directly upload images. You click on any desired location, you can immediately get access to the high-resolution image, and while you're looking at the 3D environment with a high-resolution image as an overlay, you'll be able to do all kinds of measurements and annotations that I mentioned before. Being able to do this over time, we wanted to test this on various sites. So in this case, you can actually see probably around 15 or 20 captures that was used as part of this assessment. Now, when it comes to integration with BIM, we've looked into a number of capabilities on two sides. One, mostly we've looked into the unique capabilities that CCC brings by being able to bring BIM to mobile phones. This happens to be a different version of a BIM rendering capability that is doing this in a web-based environment. So the intent is to bring BIM, be able to get access to the same information you have in coordination. Now, the next piece of this is progress tracking. So we need to form what we call a production level 4D BIM. And as part of that, it's important to be able to tie in project schedule to BIM. So we worked on a number of capabilities to take advantage of work breakdown structure and perhaps automate several steps in the mapping of tasks to BIM elements. So we can save, let's say, somewhere between 30 to 40% of time that is typically spent on creating 4D BIM. Once the 4D BIM is created, you'll be able to use that as a basis of tracking progress. You can understand production rates on a daily basis and have that contrasted with reality, those bubbles that you see on the top. So in this case, I just turned that point cloud off. You're looking at a very standard 4D BIM, but this time done in a web-based environment, and then go ahead and overlay point cloud. The user can change the date associated with point cloud at any time, and within this web-based environment, you'll be able to get access to a different point cloud, a different point in time, and now you can contrast reality versus the plan. So when it comes to predictive data analytics, we tapped into research that we've done in the past, and we started looking into how we can contrast expected versus actual, and be able to report percent progress per task, per element, per work package. Automation can be done if visual data is being done at a high frequency, but we think that even if that's done automatically, there will be a significant large number of tasks that will still require manual input. So this is where there's a major power of using a mobile solution like CCC's C3D, because you can tap into BIM and the expertise of the trades that are conducting the work, have them report directly in the BIM for you so you can do quantity-based progress tracking, but then use the visual data, your point clouds and images, as a layer of verification, as a layer that you can actually use that for verifying their billing, verifying completion of the work, use that as a basis of your punch list, or even communication on the job site. If you ask them to provide that input, you can also tap into crew size information. And if you get access to crew size information, now you can connect your input to output, and you can start providing productivity information. Now, one of the things that we've done is to tap into machine learning and use the trends that we see on progress and productivity to identify risk. And we've devised a workflow that is consistent with what we typically do in any project control setting, which is measuring and communicating risk per work package. So instead of being retroactive and only measure PPC or earned value analysis metrics, we measure risk for potential delays. So in this case, the video you see on the screen, the superintendent has highlighted a number of locations that are at risk for potential delays. He's walking the trades and the subs, one location at a time, documenting the root causes, task constraints. What are the RFIs? What are the submittals? What are the punch items that we need to address before we can commit to our task in the future? So we can collaboratively revise the look at the schedule and automatically see the 4D BIM being updated. And we can run that to make sure all the trades are on the same page in terms of who does what work in what location, get buy-in from them on the work, and conduct the work as planned. So we've done a number of assessments on the potential of using visual production models. One thing is clear, more than anything, this improves our capability of coordinating work on the job site. So in this case, over a span of 6 weeks, we tracked a number of metrics that were relevant to the site, being able to tap into PPC, number of times that the tasks were being delayed and repeated. And we're able to show that access to actionable data can help project teams improve their own performance. We can significantly improve PPC and minimize the number of times that the tasks are being delayed or repeated. So let me be very clear on how this could be achieved. So as part of this examination, we wanted to look into what are the root causes that typically lead to issues that we have with our coordination. Number one that we typically see on many job sites is frequent changes in work plan. This is actually mostly relevant to projects where you're adopting weekly work planning process. So what we did in this case was to offer progress and risk reports that would highlight locations and workflows for the superintendents that these locations are at risk for delays. So the superintendent now has actionable data that it can use to improve reliability of the project schedule. The second issue that we observe is oftentimes work areas are simply not available or the handoffs are not being completed. So the fact that the system can provide you with knowledge of who is doing what work in what location every day, it provides you with real-time knowledge of task completion, especially if it's done through a mobile phone device like what C3D solution does, availability of workspaces, and being able to have them access to the backlog of tasks that they can commit to. Now you're bringing the power of planning to the personnel that you have on the job set, enabling them to contrast what exactly gets done on the job set versus the plan, and use that as a basis of improving your coordination. And lastly, obviously, underestimated effort. This is a major issue with respect to lack of skilled workforce. So we think that this underestimated effort can be addressed by having access to actionable productivity information. If you gauge productivity per work package, per trade every day, now your superintendent will be able to tap into this data and use that as a base of improving the plan. So again, I go back to the numbers that I showed you earlier, and I just want to summarize it by mentioning that improving coordination is a factor of having access to actionable data. Data that can provide you with that feedback to your plan that is timely, that is accurate, and is verifiable because it's based on visual data. So what are the takeaways? Based on things that we've shown you today, we want you to have a few takeaways. One, you can tap into your existing visual data. What you saw from the quick poll report clearly showed you that visual data already exists on your job site. You can use that to improve the basis of your planning, achieve an enhanced coordination, and use that environment within cloud-based or mobile phone apps for the purpose of communication and field reporting. More than anything, a system like that can provide you with transparent process view, a view that would let you contrast reality with a plan. You can achieve more predictable plans if you start adapting this as part of your workflows. Real-time field reporting, which is a specific use case that we looked at as part of our assessment of Mars rover. A streamlined billing. The visual data can provide you with a layer of verification. For every work package, you have access to BIM, and solutions like C3D can give you access to the quantities. You can access quantity expected versus reality from the visual data, and you can use that as a basis of billing on an objective verification of the work. I'm not going to comment much on quality control. A lot of Fiatech members have tapped into this significantly. Another additional value of visual production models, and safer operations. Your regional safety engineers can sit in an office, get access to a cloud-based system through a web browser, and see multiple projects, annotate them for safety as it relates to their plan, as it relates to the reality on the job site. And you can also share the same environment with your trades and subs. So we think that this is a system that brings owners, contractors, and subs on the same page in terms of how much progress is being made. It provides you with access and opportunity to improve your short-term planning. It enables you to be connected to actual progress on the job site, and it offers proactive risk management capabilities. So I'm tying this to some of the issues that we mentioned early on. So all in all, it offers a win-win solution for all parties that are engaged in the project. So now I've shown you what capabilities are possible in 2017 leading to 2018. I want to speak about things that are in the roadmap. There are two elements when it comes to research that we've been exploring. One, conducting flights of drones or data capture broadly still is an issue that we want to address. So as part of that, we've looked into what are the issues that are not fully addressed on the commercial side. One being drone operation. Today, majority of the drone operations are conducted in 2D. You have lawn mowing pattern, you fly your drone over the job site without being able to achieve any autonomy around operating your drone around the structure. So when it comes to vertical structures, when it comes to capital projects, you still want to make sure that you can assess accuracy and completeness of the capture before you conduct your flight. So we also have used these visual production models as a basis of creating a 3D flight planning app. The interface is very simple. You start in 2D, you identify the area you want to map, you geofence locations that are unsafe, then you'll be able to review and revise your 3D plan in a 3D environment, and make sure before you take your drone out, you'll be able to make an assessment on accuracy and completeness of the capture. The second component of it is what we can do indoors. This was actually an initiative that was brought to us by 2 construction companies, and they wanted us to see if we can tap into commodity ground robots for the purpose of mapping. So what you see is just a prototype which moves autonomously after first manual capture, meaning that the user would manually operate this on a job site. It would learn and map the environment based on the similar algorithms that I showed you in earlier as part of the Mars rover project. Then it would be able to localize the robot with respect to that environment. This capability would let you create a map, and you can actually use this over and over in a work area and be able to map that. Now, what are the elements associated with safety? What are the elements associated with the workflow? What is the reaction of the workers? These are all things that are still in the works. But all you see is the capability of a technology that can enable a rather more autonomous capture indoors. So with that, I want to pass the token to Stuart so he can initiate our panel discussion. I wanted to just quickly offer you an insight on projects that we've done leading to these questions. Stuart?
Hi, Manny. Thanks very much for that very inclusive presentation. Can everybody hear me? Yep. I've had a number of questions during the presentation, which largely focus around being able to share the slides. We will do that afterwards. We will post it to YouTube, and everybody will be notified of its existence through the social media. So yes, it will. If you have any other questions in between, please do fire them across. But anyway, the first thing I want to do is bring both Ryan and Todd back in. Or into the presentation. We have a panel discussion now, and I have several questions here that I want to go through. And the first question I've got is the industry use cases for online BIM-driven performance tracking. I want to ask Ryan to give me some comments on that. If Ryan, you could jump in, can we hear you?
Of course. Hi everyone.
Hi.
Mostly. I think the description of the importance of visual data collection and the incorporation and tapping into visual data into the whole life cycle of what we call visual project controls was made very clear by Manny throughout, and this is what we have been working on for the last year or even a little bit more. I will just give 2 important use cases for anyone who has tried to work or worked with BIM-based progress collection and BIM-based visual project control. One important challenge is keeping the BIM up to date, with the as-built construction. Most of the time in CCC, for example, there's a lag time. Our BIM engineers who have modeled the BIM, we even have to deploy or hire BIM engineers on site, and it's normally a large team that will try to keep track and keep updating the BIM model in line with construction, and still we do have a lag of time between the BIM and the actual as-built model. So let me just real quickly show how the integration of C3D with Mars rover would mitigate this problem. I will give you a simple use case. Basically, as Manny mentioned, in C3D is available on mobiles and brings in the mobile. The importance of C3D mobile is that it brings in the mobile to the field. So on your tablet or on your mobile phone, the actual BIM model is available, or the portion of the BIM model which is under your control is available for you on site as you are doing your site walks. What's interesting is that our users go use SiteWalk and the mobile application to collect progress and to actually also another aspect is whether you're using advanced work packaging for those of you who are familiar with, or whether you're using lean construction techniques. The bottom line is that each head of trade or each superintendent or each head of crews will have with him a work order, a list of things that he needs to do this week. And while doing his site walks, he needs to update this progress. And for the items that he couldn't finish, he needs to issue some comments, take some photos, do some punch listing. What we are offering extra here, what the synergy between two technologies, is that now as you're navigating your BIM model, first you can locate yourself based on without any GPS, because most of the projects you are in an underground, or you are doing a tunnel or infrastructure, you don't necessarily have internet connection, so you are in an occasionally connected environment. In most of these projects, you don't have GPS to locate yourself, so we use Mars rover to locate and to tap into the actual visual data, whether it's coming from video cameras, from drones, from robots, or from laser scanning. We tap into them, and then we pick up the photo, and we superimpose the photo over every and single task. So let's say somebody is saying, I have finished tiling in this room. So once he's updating his progress, he will get the actual visual of the tiling being finished, and he will tap into it and connect it to his report. And this way, he will have an authentic visual report that is used to even support his claim of progress. Now, this is going down to the level of one superintendent at a time. But let's zoom out and see what does this mean at the level of the project. If we collect all those updates, then per work package or per zones, we will be able to feed back to the this visual data, and this visual data will be used as an help or aid for the BIM engineer to update his BIM model. This is now, but looking a little bit into the future, maybe a 2020 vision, we are heavily using and starting to learn with artificial intelligence based or machine learning based algorithms that will allow us to compare, actually to automatically detect the progress and give a suggestion to the guy who's filling in his progress, that, for example, the visual data indicates that you have finished 70% of the columns in floor 1. Or if you're doing a road project, let's say that the visual data collected is telling us that you have finished the asphalt work of kilometer 101 to 102.
Okay.
And
Thanks,
then you
Ryan.
keep this feedback.
Sorry, Ryan, go on. I'm just conscious of the time. I'd like to get through a couple more questions.
I think I'm done.
Thank you for that. Thank you for that. That covers it comprehensively. I'm going to move on to the next question. I'm going to bring Todd in. So, Todd, the next one we got on the discussion is outdoors versus indoors and challenges and opportunities. Do you want to give us your perspective, how you see that with the data capture?
Yes. Well, first of all, in the outdoors, some of the issues that we've had with that is placement of cameras and trying to get the right vantage point. So using the UAVs, the drones were able to capture more depth outdoors, and it relates to our heavy highway projects where we're dealing with exclusively outdoor projects covering several miles of space. One project could be anywhere between 5 to 20 miles, and so that's a lot of coverage area that we need to cover, and a lot of that's related that we've been working or looking at the upcoming regulations here in the U.S. with the FAA regarding the LANC, the low altitude and notification system, and get authorization. So that system's being rolled out 5 cities right now, 50 by the end of the year, and across the U.S. Hopefully by summer of 2018.
Okay.
Is the prospect. So and indoors, some of those solutions that we've been looking at through Mars rover that Mandy pointed out in the presentation, and so we started implementing the 360 cameras to capture indoor locations, as well as action cams and just regular the smartphone cameras and tablets.
Okay, thanks for that, Todd. I'm going to move on to the next one we got here, the crowdsourced visual data capture versus the professional. Rami, I know you're on the call. Rami, is that something you want to give us your perspective on?
Yeah, like for professional cameras, we usually take them per weekly or something. For crowdsourced, we will be benefiting from updating the point clouds somehow like real time, because we're getting always images from people using them for updating progress, for doing snagging. So all these images will be used to update and enhance the point cloud, which will give us as well data on the as-built, like for real-time data.
Okay, thank you, Rami. I'm going to move on to the fourth one we've got here. It was a bit short of time, so if we can have 30 seconds on that. I'm going to bring Manny in. Manny, do you want to give us your overview on the strategic initiatives around the use of visual data?
Absolutely. We've had the pleasure of working with Zachary and CCC on their initiatives in terms of using visual data, and specifically with Zachary on using drones. We've also had the opportunity of working with a few other companies on the usage of visual data, specifically on drones, laser scanning, and ground images. It's very exciting to see FAA's improving regulations when it comes to safety and requirements. So it's enabling more autonomy around data capture. With more autonomy, the return on investment on using technologies like this for the purpose of streamlining billing, field reporting capabilities will be significantly enhanced.
Okay, thank you, Manny, for that. Okay, so the next one we've got there is the integration of autonomous data capture platforms, so drones and ground robots. Todd, I think this one's for you. Could you give us 30 seconds on that one, please?
Sure. Yeah, I've kind of covered it in the first question regarding the drones, but you know, this is an area where the automation and not just the you know, having the autonomous and a lot of times people refer to it as swarms, but have the autonomous data capture available will also you know, how it is only going to be enhanced as we integrate those with our safety programs, and as you mentioned before, regarding the FAA regulations to allow for those you know, on a more widespread data capture. So one of the initiatives recently too is the UAS integration pilot program, which is going to be really looking at municipalities, state, local, and tribal organizations to really implement research projects around this type of new technologies as we go forward.
Okay, thank you, Todd. I'm going to bring Ryan in for the question 6 there, and then finally I'll answer question 7. But the return on investment on visual production management systems. Ryan, do you want to give us 30 seconds on that, please?
Quickly, I think looking at bridging the gap between the actual BIM versus the in place as built with the design, the preciseness in collecting data, talking about progress being real progress, not just progress being filled in field reports and on paper on mobiles. All this, logically speaking, will have a big return on investment. I know actually it will be a very good research topic for somebody to go and measure the improvements on an actual project after using all this new technology, all this new methodology. But definitely and logically speaking, there's a big return on investment, and it will. We believe it will increase efficiency of a project in a big percentage, not just in 1 or 2%.
Thank you, Ryan.
I just may add something to that, if you don't mind, Stuart.
Yeah, go on.
Everyone who's a member of Fiatech knows that there's no doubt about the impact of planning on the projects. Good planning requires good data. A data that is actionable, a data that shows you the reality of the job site. And visual data can provide you with that feedback so you can actually create better plans.
Thank you, Manny.
Absolutely.
Thank you. Okay, so the final one we've got here is the Horizon 2020. In Fiatech, we call that Horizon 360. What's emerging, what's upcoming, what are the opportunities around visual data? We have lots of discussions about it. It's what Fiatech, it's what Comet do. This is the arena. It looks for the future. How can we bring it in? How can we develop it? How can we deploy it? what I would urge you to do, you've heard a lot about Mars rover today. Get a look at it, get a closer look. Please do revisit, get in touch. But it is about what we can do in the future to make the capital projects world a better place. The technology is emerging, it is available, it is usable. Have a look, have a look. So what I will say is thanks very much for our panelists, to Manny, to Rami, Ryan and Todd. Thanks very much for your participation. Thanks for Manny for the main presentation. I just want to close out with a couple of things here. We have a couple of things I want to mention. There's the Fiatech Tech Showcase, which is in March 19 to 21 in San Antonio next year. We also have the Comet Community Day, which is in Bentley Systems on the 8th of March in London, UK. I'd also like to say thank you very much for joining us on this session and also the previous sessions throughout this year. If you do have any questions, then please do get in touch with myself. And finally, join the conversation in any of those social media links there. We will post the presentation on YouTube in a matter of days. There is a follow-up survey. Please do complete that if you can. But finally, anything from anybody else before I close it out? Manny, Ryan, Rami, Todd, do you want to have any parting words?
It's been an absolute pleasure to work with the team. I'd like to encourage those of you who are interested in listening to us today, contact Ryan, Rami, Todd, Stuart, and myself. And we'd be more than happy to tell you what we've done, what you can use today based on things that you've seen. And if you're interested in conducting a pilot project through Fiatech, we'd be happy to discuss that with you. I also want to acknowledge the support of Yui Fen, the graduate student at the University of Illinois, who's been part of this project.
And I would like to encourage all attendees whose companies are actually Fiatech members. You have access to all this research and all this information. Please feel free again to contact us, so that you can, in case you need to conduct any pilot project or even just get more info about the project.
Thanks, guys. Have a great day.
Thank you.
Cheers now.
Merry Christmas and happy holidays, guys.
Thank you.
Yeah, same to you.
You too. Yeah.
Thank you.